Hello and welcome back to High Peak Education. I would like to perform a calculation with electric transformers now. And we're going to assume these are ideal electric transformers where the energy and thus the energy per time the power is retained. That's definitely an assumption, but we're just going to go with it. So it says a laptop computer transformer has 500 turns of the primary winding and then 10 turns of the secondary winding. A. Determine the secondary voltage if the secondary circuit is open and the primary voltage is 120 volts. B. Determine the current in the primary and the secondary winding given the secondary winding is connected to a resistance load of 15 ohms. Alright, so let's go ahead and write down our knowns. So there's 500 turns in the primary. So that's NP is 500. Remember, this is just turns, which is unitless. 10 turns on the secondary winding. So NS on the secondary is just 10 turns. Okay. Determine the secondary voltage. So we want VS. If the secondary circuit is open and the primary voltage is 120 volts. So V primary is 120 volts. Pretty standard for the United States of America. So the great thing about transformers is that the primary to the secondary number of turns to voltage is just a ratio. Okay. And we can solve this for Vs. We can just go ahead and cross multiply. So we get NPVS equals NSVP. And let's go ahead and get Vs out of that. So Vs equals NSVP over NP. So the numbers go in. So the number of secondary turns is 10 turns. The voltage on the primary is 120 volts, and then the number of turns on the primary was 500 turns. Now, this ends up being 10 over 500, which is 1 over 50. Now, 1 over 50, I think, is the same thing as 2 over 100. So that's 2 hundredths. So 1 hundredth of 120 should be 1.2. So 2 hundredths, I think, should be 2.4. And that should be volts. Okay, so 2.4 volts is on the secondary. So this is definitely a step down transformer because we step the voltage down from 120 volts to 2.4 volts. Furthermore, we step the number of turns down from 500 to 10 turns. Okay, let's look at part B. Determine the current on the primary and the secondary winding given that the secondary winding is connected to a resistance load of 15 ohms. Well, I think we need to start solving on the secondary first. The resistance on the secondary is 15 ohms, and I think we can use Ohm's law because we have the voltage. So the current on the secondary should be voltage on the secondary divided by resistance on the secondary. So that's 2.4 volts over the resistance of the secondary is 15 ohms. So we calculate 2.4 divided by 15. So we've got 0.16, that's amperes. 0.16 amperes. So that's the current on the secondary. Now how about the current on the primary? If the power is conserved, then I primary, V primary, is equal to I secondary, V secondary. Now notice, we should be able to solve for the current on the primary because we have the voltages and we now have the current on the secondary. So I on the primary is I secondary, V secondary, divided by V primary. And the numbers can go in. So this is 0.16 amperes times voltage on the secondary is 2.4 volts. And the voltage on the primary we said was 120 volts. So calculator, alpha F1 numerator over denominator. So let's go 0.16 times 2.4 and divide that by 120. Let's hit enter. That's 0.0032. So this is equal to 0.0032 amperes, which, again, giving you a little bit of context, that should be 3.2 milliamperes. So remember that on primary transformers, the current is typically very small, but the voltage is higher. Whereas on secondary transformers, when we have a step down, the voltage steps down, but the current goes up in order for power to be conserved. So this idea is we're using the conservation of energy, but just energy per time, which is power. So that ends this problem. Thank you very much for your attention. Please smash that like button if you enjoy this content. Please subscribe to the channel to grow the channel. If you please, share this with your social network, and I look forward to your comments. And I will also look forward to seeing you in the next video.